Hi everyone, welcome to yet another episode on Basics of MATLAB Programming. In this tutorial, let us discuss matrix operation in MATLAB Programming. Matrices are a two-dimensional array. There are few special cases in matrix that are column vector and row vector. Say for example, A where A represents row vector has a dimension of 1 cross 9. Let me check the dimension of this matrix. For that, size of A. So it is 1 cross 9. That is 1 row, 9 columns. So it is called row vector. Similarly, we can have a column vector. Say for example, B have a look at this. B represents column vector. There are 9 rows and 1 column. Let me check the size of this matrix, that is dimension. So it is 9 cross 1. Now look at the difference between row vector and column vector. A represents row vector. The numbers are simply separated by the space. B represents your column vector. Each row separated by a semicolon. That's the difference between column vector and row vector. Then, how to enter a matrix? As I said earlier, matrix is m cross n dimension. That is m rows, n columns. Let me take a sample. A again. 1, 2, 3. So this is first row. Then I have to separate this by semicolon. Second row. Third row. Now have a look at this. A has 3 cross 3 dimension. That is 3 rows and 3 columns. Each number separated by a space in this column and each row separated by semicolon on this matrix. Check the dimension of this matrix. Size A, in fact capital letter A, it is 3 cross 3 dimension. Then indexing a matrix. Indexing a matrix is quite simple here in the case of MATLAB. This is 1, 1. This 1 represented by A of 1, 1. First row, first column. This 4, 2, 1. Second row, first column. Let me check the indexing, whether it is right or wrong. I want to print that 9 here, so that indexing is 3, 3. Let me check it out. A of 3, 3. It's going to be 9. Similarly, you can check any other value. A of 1, 3 is 3 actually. A of 1, 3. Check it out, the answer. First row, third column. First row, third column is 3. That is your answer. Then, how to create submatrix? Let me take an example of same A. So from this, I want to create submatrix. Submatrix means only sum of the elements. Say for example, I want to consider only this 4, 5 and 7, 8. I want to separate this 4, 5, 7, 8 from this A matrix. For that, you take A of 4, 5, 7, 8. So 4 is second row, 7, 8 belongs to third row. You take down 2 and 3, second and third row, comma, then open square bracket, first column and second column, 1 and 2. Now check it out, 4, 5, 7, 8. 2, 3, that is second row and third row. So second row, third row means these things. But in the second row and third row, I need only first column, second column. First and second column, 4, 5, 7, 8. That is what the answer here. Let me go for another example of creating submatrix. This time I want to take 2, 3, 5, 6. How can I do that? A, open square bracket, remember first row, second row, 1, 2, comma, then second column, third column, second column, third column. Check out this 2, 3, 5, 6. That is first row, second row, and second column, third column. These are the things I required. Then let us now understand how to swap rows or columns. To do so, let me take same example of A, 3 cross 3 matrix. Now say for example I want to swap first row and second row. To do so, A, 2, 1, 3. Now, so in place of first row I am keeping second row. In place of second row I am keeping first row. I am not disturbing third row. Let me check out this answer. So have a look at this 4, 5, 6. Actually second row here, that comes under first row. Similarly 1, 2, 3. First row here, that comes under second row. So this is how to swap rows. Similarly you can swap column. Say for example A, let me swap first and second column. Now check it out. I am swapping 147 with 258. Now look at this. 147 is here, the second column, 258 in the first column. So this is how to swap two columns. Let us understand how to delete a row or column in a matrix. I have a matrix as usual. I want to delete first row 1, 2, 3. To do so, represent that row vector A1. This is the representation of first row and make it as empty vector. Now see the answer. A has 4, 5, 6, 7, 8, 9, but not 1, 2, 3. So we have deleted first row. Now I want to delete this first column. Represent a column vector A1 and equate the same to null or empty vector. Now have a look at this. First column is deleted from your matrix. So only we have 5, 6, 8, 9. So this is how to delete a row or column. Next, let us understand how to concatenate a matrix. For example, take A matrix. Now I want to add further 3 cross 3 matrix on this right hand side such that this becomes 3 cross 6 matrix. How can I do that? B is equal to A. So have a look at the result. A is 3 cross 3 matrix added here once again to produce B matrix with 3 cross 6 dimension. Similarly, I can add few rows in this B matrix. Have a look at this. C square bracket B semicolon B. Have a look at this answer. The B matrix is added again here as a row such that producing 6 cross 6 matrix. So you can concatenate matrix in a matrix. Then MATLAB has number of inbuilt functions which is used to generate different matrices. Let us discuss one by one. EYE of n, let me choose n as 3, returns square identity matrix. If you go for EYE hyphen 4, 3, it returns 1 on main diagonal element, other numbers are 0. You can also generate random number in a matrix. Say for example 3, 3. It returns some random number with the dimension of 3 cross 3. If you want to select any diagonal element from DIAG of DIAG of answer produces only diagonal element. Have a look at this: 0.8147, 0.6324, 0.9575. You can also generate some matrix full of 1 and full of zeros. Say for example ONES of 3, 3. You see this 3, 3 dimension, all the elements of the matrix has a value of 1. Similarly zeros, 3, 3. All the 3 cross 3 elements are 0. There are few matrix functions performed in MATLAB, namely determinant of the matrix, inverse, transpose, like that. Let me take a simple 2 cross 2 matrix. Determinant of this matrix, det of this A. Det of A, capital letter A. So it is -1. Similarly, you can calculate other mathematical functions, eigenvalues, EIG. Simply you put EIG of A, it will return eigenvalues and eigenvector. Then you can also go for inverse of this matrix A. Go for INV of this A. So inverse of this matrix can be easily obtained. Even transpose of the matrix can be easily obtained here. A for a transpose, single quote. Use single quote. Actually A is have a look at this, 1 2 3 5. Now it has been 1 3 2 5. These are the mathematical functions can be performed in MATLAB. MATLAB also performs arithmetic operation. Say for example A, B. Now I can perform addition here, A plus B. So it is simply addition of two matrices. I can also go for C is equal to A minus B, subtraction. So since both the values are equal, it is giving 0 value. Multiplication, finally division. You can also have square of the matrix. a square. This is actually a star a. C is equal to a star a. Same answer will come. Apart from this operation, MATLAB permits element-wise multiplication, element-wise division, and element-wise square. To perform these things, element-wise multiplication, have a look at this operation a dot star b. So this operation performs element-wise multiplication. So a and b has 1, 2, 3, 4. So element-wise multiplication is done. Similarly, element-wise division. C is equal to a dot division b. Now the answer is going to be 1, all the 4 elements of this matrix, since a and b has the same elements. And let's go for a's element-wise square. Since element-wise square means each element is squared here, it's going to be 1, 4, 9, 16. These are the arithmetic operation performed in MATLAB. I hope you enjoyed this tutorial with the learning of matrix manipulation and arithmetic operation in MATLAB. To get more updates, subscribe my channel.